Hello and welcome. Today we're going to explore a powerful tool used in total quality management, the failure mode and effects analysis, also known as FMEA. This method is essential for identifying and eliminating potential failures before they occur, ensuring quality and reliability in major processes. By the end of this session, you'll understand what FMEA is and how it fits into TQM, how to implement FMEA for major processes, a detailed real-world example of FMEA in action, and common pitfalls and best practices when using FMEA. Let's begin. FMEA is a systematic, proactive approach to identifying where and how a process might fail. It assesses the impact of different failure modes and helps prioritize actions to mitigate risks. This methodology was originally developed by the U.S. military in the 1940s, but has since been widely adopted in industries like manufacturing, healthcare, aerospace, and software development. FMEA aligns with the principles of TQM, which emphasize continuous improvement, defect prevention, and process optimization. By applying FMEA, organizations can reduce waste, improve efficiency, and enhance customer satisfaction. To put it simply, FMEA helps answer three critical questions. What could go wrong, what would be the consequences, and how can we prevent or detect it before it happens? This method is especially useful in high-stakes industries, where failures can lead to major financial losses, safety hazards, or customer dissatisfaction. Implementing FMEA involves a structured approach. Here are the key steps you will need to follow. First, select a process or product. Identify the process or system to be analyzed. It could be a manufacturing process, customer service workflow, or even a software application. For example, suppose we are manufacturing automobile airbags. Since safety is crucial, we want to identify any possible failures before production. Next, form a cross-functional team. Bring together experts from different areas who understand the process, including engineers, quality managers, operators, and customer representatives. Why? Different perspectives ensure all possible failure points are identified. Then, identify potential failure modes. List all possible ways a process could fail. Think of everything that could go wrong. For instance, for airbags, a failure mode could be airbag fails to deploy in a crash. After that, determine the effects of each failure mode. Define the consequences of each failure. Does it lead to a safety hazard? Does it cause defects? Does it delay production? For example, if an airbag doesn't deploy, the driver and passengers could suffer serious injuries. Next, assign severity, occurrence, and detection ratings. Severity, or S, rates the impact of the failure from 1 to 10, with 1 being negligible and 10 being catastrophic. Occurrence, or O, rates the likelihood of failure happening from 1 to 10, with 1 being rare and 10 being frequent. Detection, or D, rates how easily the failure can be detected before reaching the customer from 1 to 10, with 1 being easily detected and 10 being undetectable. If no test can catch the failure before shipping, the score is high. Then, calculate the risk priority number, or RPN. RPN equals severity times occurrence times detection. The higher the RPN, the greater the need for action. Finally, develop an action plan. Address the highest priority risks first. Implement changes to reduce occurrence or improve detection. For example, to reduce airbag deployment failure, we might improve sensor accuracy or increase quality checks before assembly. And remember, monitor and review. FMEA is a living document. Regularly update it based on new data and process improvements. Now let's go through a real-world example of FMEA applied to a car braking system in an automotive plant. 1. The process analyzed in this example is a car braking system. 2. Our potential failure mode is the brake pads wear out too quickly. 3. The effects of failure are reduced braking efficiency and increased stopping distance. This increases the possibility of accidents and introduces safety risks. 4. Our severity, or S rating in this case, is a 9, which indicates a critical safety risk. This value was chosen based on the potential for severe accidents and injuries if the braking system fails. 5. The occurrence, or O rating in this case, is a 7 for a frequent issue based on past data. This rating was determined by analyzing historical data on brake pad wear and failure rates in similar models. 6. Detection or derating, we are going to assign a 6. This means it is difficult to detect early without thorough inspections. 7. Now, our RPN calculation give us 9 times 7 times 6. This gives us an RPN number of 378. This is a high risk that needs immediate attention. 8. Corrective actions. For this example, we recommend implementing new material for brake pads to improve durability, introduce sensors to monitor pad wear and alert drivers to increase frequency of routine inspections. 9. Post-implementation review. After the implementation of the corrective actions and testing, the new brake pad material extends lifespan by 30%, and the sensors help detect wear early, reducing accidents. Recalculating the RPN has shown a significant reduction from 378 down to 126, indicating a lower risk. While FMEA is an effective tool, many organizations face challenges when implementing it. Here are some common mistakes and pitfalls to watch out for. 1. Failing to involve the right stakeholders, like not consulting operators or engineers. 2. Not updating FMEA regularly when new risks emerge. And 3. Ignoring moderate risk failure modes, which can accumulate over time. These pitfalls can be avoided by following some best practices. For example, 1. Schedule regular FMEA reviews quarterly or annually. 2. Use historical data to refine occurrence ratings. And 3. Train employees on FMEA to ensure consistent application and continuous improvement on your processes. To sum up, FMEA is a crucial tool in TQM that helps organizations anticipate and mitigate risks before they escalate. By systematically analyzing failure modes, prioritizing risks, and implementing corrective actions, businesses can achieve higher quality, efficiency, and customer satisfaction. If you found this session helpful, consider applying FMEA to your own processes to drive improvement. Thank you for watching, and feel free to reach out with any questions. Check out our other training videos in this series where we continue to delve deeper into the 6 pillars of total quality management, as well as tools, benefits, and how to implement TQM in your organization. Thank you for joining, and don't forget to subscribe for new videos from All Things Quality.